Assalamu alaikum wa rahmatullah. As usual, today we are still going to continue from where we stopped on our previous lesson. If you didn't view our previous lesson, you better go over from the beginning and start from what we did. That is the formulas of calculating how to find a work done. And last lesson, I gave a way we can be able to find to attempt any physics problem. Today we are going to look at three examples of the work using different formulas to find this particular work. Then example number one says a body is pulled by a constant force of 10 Newton. Calculate the work done in moving the body to a distance of 5 meters. The steps we are going to follow, previous steps. Let's start from step number one. Step number one, we see we can write our data given. That is number one. After writing our data given, then we read the question and pick out the known and unknown given values. Then it says a body is pulled by a constant force of 10 Newton. The whole of this statement, the only thing we want here is the force. Then we write we have a force F, which is 10 Newton, comma. Calculate the work done. Since we were asked to calculate, I told you they may say calculate, find. Okay, so then we say work done as W. Work done, W is unknown. That is what we are looking for. In moving the body to a distance of 5 meters, then we say distance S is 5 meters. We pick out everything here from the question. Now, if you look at the data, we only pick out the quantities or the values needed on this calculation. We have everything here. Then the second thing that a student will think, that is, which formula is desirable for us to solve this problem, which we know. Straight formula, then we can say that, or we can say using work done, that is the first formula, work done is equals to force times distance, which is desirable. Force is given, distance is given. We were asked to find the work. That is why we see, since the work done is the subject of the formula, we don't need any simplification here. We only substitute our value and solve our problem. Then we can say W is equals to F times S. Then W is equals to, what is the force? Force is given as 10 Newton multiplied by distance is what? 5 meters. Then our work done will be equals to 10 multiplied by 5 will give us 50. The SI unit of work is joules. 50 joules. That's about this case. So you see, since we pick out our data given, this question has never been a problem to us. Why? Because after picking out our data, it is easier for us to recall and think of the desirable formula to be used. That is about this question. Then on in case number 2, that is example number 2, it says a body of mass, a boy of mass 50 kg runs off 10 steps, each of 0.2 meters. Find the work done against the gravity. Take G as 10 meters per second squared. On this case, students may rush in solving this problem by still taking their formula. They take 0.2 is the meters is the distance. No. Let me start with this. Our data given. After getting our data, let's understand the question first. A boy of mass. Let me write a small diagram. This is a boy, for instance. The mass of this boy is 50 kg. Then they say he runs 10 steps. This is the floor. Then this is the step. 1, 2, 3, 4, 5, 6, 7, 8, 9, and step 10. Fine. These are the steps that this boy runs up to the boy, reach the 10 steps. Then it says each step here, each of these steps is 0.2, 0.2 m, 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 0, up to the last stage. That the whole of 10 stages. Each of the stage height is 0.2 meters. So for us to find a total height, what are we going to see? We say our h in this case will be each 0.2 meters multiplied by how many steps do we have? 10, which will give us our height is 2 meters. That is the height. Then this is what we have. Then find the work done. We were asked to find the work done. Then they say work done is unknown. Then take G. G is given as 10 meter per second square. On this case, if you look at this, take note, a student has an option if G is not being given. You may either use 9.8 or 10 meter per second square, but on a condition that G is given, you must use the value given to you to solve that problem. For instance now, if that G is not given as 10 but given as 9.8, you must use 9.8. If it is not given, you may use 9.8 or 10 meter per second square because it is all constant and acknowledged. Fine. Then, if a student will easily think, we have our work, we were asked to find the work done, G is given, height is given, mass is given as 50. Then what? The real formula against the gravity is what? Work done is equals to mgh. Then our work done will be equals to mass is 50, multiplied by G is 10, multiplied by 2. Work done will be equals to 50 times 10 will give us 500. 500 times 2 will give us 100 joules. That is about this case. Then on this final one, a body is pulled 10 meters to a horizontal plane by a constant force of 15 Newton, which acts 60 degrees to the floor. Calculate the work done by the force. Let me still write our data given. A body is pulled 10 meters. 10 meters is what? Then we can say we have a distance. S is 10 meters. Horizontal by a force, horizontal plane, by a constant force of 15 Newton. Then we can say we have a force. F is equals to 15 Newton, which at 60 degrees, you don't need to be, you know 60 degrees is our angle, direction of that force, which is 60 degrees. To the floor, calculate the work done. We were asked to find work done. W is unknown. Definitely a student knows the formula desirable to use is W equals to F cos theta times distance, or F times S cos theta is all the same. Then we substitute our value. What is the force? Force is given as 15 multiplied by cos 60 degrees multiplied by what is the distance? 15. Then our work done, if you calculate it, will give you 75 joules. Now, you see how we can solve a work done using the first formula that says work done equals to force times distance. You see how we solve a work case using the second formula, W equals to mgh. You see how we solve a work done using the third formula, W equals to F cos theta times a distance. So I believe using these three terminologies, a student can be able to solve any Workdone problem. Thank you. Don't forget to subscribe my channel, press alarm for more videos, drop your comment. Thank you.